Okay, so today we're diving into something pretty cool. It's this fascinating area where robotics kind of meets the natural world.
Okay.
Specifically, we're looking at how new AI is giving robots the ability to move with the agility of, like squirrels.
Oh, wow.
Yeah, like, those little guys that are leaping all over the place.
Right.
We're going to look at a robot called Salto, and that's actually inspired by squirrels.
Hmm.
And the AI that gives it some pretty amazing capabilities. Actually, this was recently featured on the podcast de Philippe.
Oh, I know that one, yeah.
Yeah, really interesting stuff. So if you're into this kind of exploration, we'd love to hit 1,000 YouTube subscribers today.
Okay, yeah.
So
Let's get into it then.
yeah, so I mean, it's amazing, right, how nature can just spark all this innovation in tech.
It really is.
I mean, the agility of squirrels, how they leap and land on these tiny surfaces, it's mesmerizing.
Oh, yeah, for sure.
And that's exactly what got the engineers and roboticists thinking.
Yep.
And that's where Salto comes in. It's this single-legged robot developed at the University of Illinois.
Single-legged, huh? That's interesting.
Yeah, it's wild, right? And it uses this technique called modulation of radial forces. And what that means is it can adjust its leg, how it extends and retracts during landing, which is like the most crucial part, right?
Makes sense.
And, it's kind of like how a squirrel adjusts its posture midair to stay balanced.
Oh, I see. Yeah, that makes sense.
The experiments with Salto showed it was really good at hitting its target.
Yeah, like how good?
Like 25 out of 30 trials, they landed right on the spot.
Oh, wow. Okay, that's impressive.
Yeah, so that kind of shows how effective this bio-inspired approach is for stability,
And absolutely.
But what's really cool is how AI takes this design and supercharges it.
Right.
Gives it more adaptability and precision.
Right.
And that's where that Texcali source really comes in. It talks all about AI's role.
Yeah.
So let's start with real-time dynamic control. What's the big deal there beyond just reacting quickly?
Well, it's all about how fast it can process information.
Okay.
So you have sensors like accelerometers and gyroscopes feeding data to these super sophisticated AI algorithms.
Okay.
And then those algorithms make tiny adjustments to the robot's leg force and angle.
Okay.
Like during the jump,
Right.
Basically, it's fine-tuning that radial force in response to how the movement's playing out.
Wow. So it's not just about reaction time.
No, not at all.
It's about making these complex calculations and adjustments super fast.
Exactly. In milliseconds just to stay stable.
So the AI isn't just running a program.
Okay.
It's actually sensing and responding to the environment.
In real time?
Yeah, and how the robot itself is moving.
It's wild.
It's a huge step forward.
Huge, yeah.
Another thing they talked about was advanced environmental perception.
Yeah.
How does AI give the robot a sense of what's around it?
Well, think about it like this. The robot has to understand what it's reacting to.
Right.
So it uses LiDAR sensors and 3D cameras.
Mm.
And those are hooked up to AI-powered computer vision.
Oh, okay.
This lets Salto analyze the landing spot.
Right.
Is this branch stable or is the ground bumpy?
Okay.
Sort of like how autonomous mobile robots get around in factories.
Okay.
And this tells the robot, what angle to approach from and how to land.
So it's like the robot's actually seeing and feeling the landing spot.
Right before it even gets there.
Wow. That's incredible.
It's pretty cool.
Okay, so there's this thing called reinforcement learning.
Yeah.
Which sounds like a really cool way to teach a robot to be agile.
It is.
What's the basic idea that makes it so good for these complex movements?
Well, the key is it's iterative. So it's perfect for learning complex motor skills in these ever-changing environments.
Okay.
So the robot basically practices in a virtual world,
Okay.
doing tons of jumps and landings.
Okay.
And it uses machine learning algorithms to get feedback,
Hmm.
like a reward if it does well and a penalty if it messes up.
Right.
And over time, it figures out the best way to move based on all these experiences.
Okay.
This way it can handle all sorts of situations.
Wow.
It's kind of like how Intel uses it to make their industrial robots work better.
So it's not like someone has to program every single possible scenario?
No way.
It's more like the robot just learns by trial and error.
And it gets better every time.
That's so cool.
Yeah.
The sources also mention something called contextual decision-making.
Right.
So how does AI help the robot make smart choices, depending on the situation?
Imagine the robot's jumping and suddenly there's an obstacle in the way.
Oh.
Or maybe it's low on power.
Okay.
AI is looking at all these things in real time,
Okay.
along with its main goal of landing safely.
Right.
It's kind of like how those autonomous mobile robots can change their route to avoid bumping into stuff.
Okay.
The squirrel robot could change its jump or even pick a different spot to land.
Wow.
That way it can complete its mission and not, crash and burn.
Yeah, so it's not just about nailing the jump in a perfect scenario.
No.
It's about making the best jump possible given what's happening around it.
Exactly.
Okay, last one. How does AI play a role in energy optimization for these robots?
Energy efficiency is huge for any robot that moves around.
Right.
AI uses these predictive models to look at things like how far the jump is, how accurate it needs to be, and how much power the robot has left. Then it adjusts the power needed for the jump.
Okay.
This is similar to what those autonomous farm robots use to work longer in the fields.
Right.
Basically, Salto can do a bunch of agile moves without draining its battery super fast.
So it seems like AI is what really makes these squirrel-inspired designs work.
It is. It's the key.
But I bet building a one-legged agile robot is super challenging.
Oh, yeah, definitely.
What are some of the biggest technical hurdles they're facing?
Well, you hit the nail on the head. Staying balanced on one leg is hard enough,
Right.
especially when you're landing.
Yeah.
That's why that radial force modulation is so important. But then you also need really precise movement control.
Oh.
The robot has to have perfect control over how its leg extends and retracts.
Right.
To make those jumps and landings consistently.
And the squirrels, they're just naturals at moving through all sorts of crazy environments.
Exactly.
So the robot has to be able to handle that too.
Yeah, narrow surfaces, uneven ground, slippery stuff.
Right.
It has to see it and adapt really quickly.
And like we talked about, energy management is a big deal.
Oh, yeah, for sure.
And then there's making all the parts smaller and lighter.
Yeah, like the actuators, sensors, control systems.
Right, but without losing performance or durability.
Right, yeah.
So it's this crazy mix of design engineering and AI to even get close to what a squirrel can do naturally.
It really is.
And if they can overcome these limitations,
yeah,
the potential is huge. They're talking about a 30 to 40% reduction in energy consumption.
That's massive.
Yeah, just from these optimized designs.
Yeah.
Think about it. Robots, this agile could be game changers.
That's
imagine them in disaster zones searching for people in places where, people or big robots can't get to.
right.
Or what about environmental monitoring in dense forests?
Yeah, up in the canopy.
And some people even talked about using them in space.
Oh, wow, in microgravity.
Yeah, it's wild.
Yeah, that's a cool idea.
So basically what we've learned is that AI is the thing that makes these squirrel-inspired robots possible.
Totally.
It's what helps them deal with the whole one-leg thing.
Yeah.
Real-time control, understanding the environment, learning and adapting,
Right.
making smart decisions and saving energy. It's amazing how nature can inspire such cool stuff in AI and robotics.
It really is.
So here's something to think about. We're seeing all this progress with AI and robotics, right?
Yeah.
These squirrel robots are a perfect example.
Yeah.
What other crazy things from nature do you think we'll see robots do in the future? And what will that mean for how we understand biology and technology?
That's a great question.
Thanks for joining us for this deep dive. It's been a blast.
Yeah, it has.